Welcome to our first breakout session of the day. We've got a treat for you. We've got the king of OWASP, the king of application security, and a good friend of mine. Jim Manico's flown here, and we have to really thank him because he left Hawaii to come here. You know, so, but he's a good supporter of the LA area. He's a good supporter of ISSA. He used to be one of the global board members for OWASP. He devotes countless hours supporting OWASP and application security and open source, evaluating code, correcting people, mentoring people, and supporting communities. So without further ado, I want to let the king take over. He's modest, so he gets a little, red from this, but that was my goal, to make him embarrassed. But let's give him a round of applause. You're going to get some good information about OWASP. So thanks, Jim.
Thank you. Hey, wait. Hey, Richard, before you get off stage, let's talk history for a second.
Sure.
What happens to kings throughout most of history, especially French history?
They lose their head.
They lose their head. So I don't like to be called king for a very specific reason. I'm just a student, Richard. I'm just
Leader.
Student. Thank you, buddy. Good to see you, Richard. Hey, thanks for being here. Off with your head. Yeah, don't ever take the king title. That's whose head comes off first. Thank you all for being here. Let's talk defense for 48 minutes and 17 seconds together. I want to talk about a project that I built with Katie Anton and Jim Bird. We're the three project leaders of the OWASP Proactive Controls. This is a top 10 list from the OWASP Foundation. We've gotten a lot of good traffic on this project. I want to talk about it as an excuse to talk about secure software. My name is Jim Manico. I'll be your speaker today. I manage several different open source projects for the OWASP Foundation for fun and to learn myself about application security with the community. I used to be on the global board at OWASP. I've been doing software development for most of my adult life. I wrote a book on secure software, and I'm from Hawaii. So that's me in a nutshell. But let's talk about the OWASP Proactive Controls. This top 10 list. Why does this matter? So the OWASP Proactive Controls was last published at the end of 2018. It's a list of top 10 security techniques that every developer needs to embrace to write secure software, to develop secure software. And this document was written by the three of us who are all primarily developers. And we had a good 2 or 3 dozen other experts around the world who participated and added comments to our project. We took the liberty at this time, when we were working on this for the first time in 2015 or so, we took the comment, we took the original document that we wrote and made it world editable with approval. So anyone in the world could anonymously provide comments. We did this because we want an open document. We want to make sure it's not just us in our ivory tower making decisions. And the original doc that we wrote and the doc that we published with community updates was significantly different and I think better. So I think that open mechanism to get updates was really powerful. And the OAuth Top 10, which at this time was really tightly curated, a bit too much, also became an open document, which made me happy to see that trend. In fact, a lot of the main projects that are documentation at OWASP, it's all moved to GitHub, where it's real easy to submit requests and do comments and submit issues. And this helps open source a lot. And now, a key note, though, this is not a standard. It's a top 10 list. Do any of you run your entire security programs based on a top 10 list? Anybody want to do that? I don't. I want a more comprehensive standard, like the OWASP Application Security Verification Standard. I can base a whole security program off this. The OWASP Top 10 Proactive Controls, and for that matter, the more famous project, the OWASP Top 10, this is just meant for awareness, to do education, to do a talk at a conference on, to introduce your developers to for the first time, to get the conversation started. Well, let's start that conversation. So this is the OWASP Top 10 Proactive Controls. We're going to define security requirements. We're going to leverage security frameworks and third-party libraries. We're going to secure our access to the database, encode and escape data to stop injection. We're going to validate everything that enters our software. Are we doing a pitch here? Wait a second. Wait. Go. Okay, you. We're going to implement digital identity. We're going to enforce access control everywhere. We're going to protect data everywhere. Implement proper security logging and monitoring so we can see what's happening during runtime events and handle errors and exceptions properly. This is like the top 10 categories of what we need to address in some way to achieve secure software. A lot of our industry is about mitigation and defense and firewalling, and these all other high-layer are using tools to scan and look for vulnerabilities. I like all that, but you're not doing security if you're hiring a pen tester. You're not doing security when you're doing an architectural analysis. This is my conjecture here. You're not doing security when you're writing stuff in a Word document. I get in a lot of trouble for saying this. A lot of people in the world of GRC, I see that as a business function, in my opinion. And we don't accomplish security by writing Word docs. We don't accomplish security by running scanning tools. You know how we accomplish security? By writing secure code. Now, by tuning a firewall properly, by working with your developers day in and day out to actually write code that is secure. Now you're doing security. And this is a painful truth nobody wants to hear. There's not a lot of money, there's not a big industry in teaching developers. There's not a lot of products and services around influencing developers. But that's how you do security. It's kind of counter to what the industry will tell you. So let's get into these techniques. Let's get into these ideas. Before we start an application security program, let's all be on the same page around what secure software is. So here's my question. Define security requirements. The question is, what do you consider a secure piece of software to be? Suppose you're building a web API, or you're building a web application, you're building a mobile app. What makes that mobile app secure? What do you think, audience? Who wants to play? What's that? Yeah, some kind of good authentication. That's a piece of it. That's about 1/10 of secure software, right? That's one of many requirements. Anybody else want to play? What do you consider a secure piece of software to be? What do you think, Richard?
No hard passwords.
No hard-coded passwords. It's a big piece of it. It's part of authentication. Keeping your libraries up to date. That's a big piece of it. These are all really good requirements. What do you think? A clear, defined input space and a defined functionality space. I only want users to execute these specific features and functions and nothing else. Go for it.
The software only does what it's supposed to do and nothing else.
That's a common answer, and I like that answer. And I hear a lot of developers giving that answer. And that's an answer I would give, but to a developer, they can't act on that. That's philosophy, right? And I have a degree in philosophy. We can talk about Nietzschean existentialism after class all day. That's wonderful. But when we get to a developer, developers are engineers. They're grinding out code throughout the day. So you know what developers want to hear? They want to hear, how do I write code securely? That's it. How do I tune this framework securely? What do I do when I'm banging out code so I'm actually doing security? And I'm telling you, our industry does a bad job of getting to that point in time. That's the question I want to ask all of you. How well are you at interfacing directly with your developer to enable their ability to write security on a day in and day out basis? And I think as an industry, we're fairly weak at that. We'd rather buy a scanner. We'd rather buy a pen tester. We'd rather buy this service. We'd rather put this firewall in place. Anything but talking to our developers. And that is a problem. So let's start by all being on the same page around what security is. From the executives to our GRC team, defining requirements, to our developers, to our pen testers. Let's all be on the same page as to what security is. This is how we have to start in secure software. The main standard from the OWASP Foundation is the OWASP Application Security Verification Standard. The recent version is version 4.0. This is led by Andrew Vanderstock, one of the original professionals in all of application security, one of the leaders of the OWASP Foundation, one of our board members, and a good human being, in my opinion, right? So he leads the charge with Daniel Cuthbert, myself, and several other project leaders to write this standard. It is a standard for verifying web applications primarily. It's broken down into many categories like authentication, session management, data protection. This is a way to manage your pen testing team and other assessment teams, it's also a way to manage your developers around what they should be doing for secure software. This is what binds all of us together so we're on the same page. Again, developers, assessment teams, management, developer leads. Now we all have a common definition as to what secure software is, and we can all go in that direction together. Now, this standard looks like this, right? There's 3 different levels. This is for every piece of software. This is for critical software. This is for, like, infrastructure software. And you'll see these granular components, like Richard and others were just saying, verify the availability of a secure coding checklist, security requirements, guideline, or policy to all developers and testers. Or verify that all authentication pathways and identity management APIs implement consistent authentication security control strength, such as that there are no weaker alternatives per the risk of the application. Like no step-down authentication, no way to log in without the password or through a weaker multi-factor mechanism. There's 200 of these minutia level requirements. Now we're doing security. When you're doing this list, when you're focusing on this level of technical detail, now you're doing security. About 200 requirements for testing and development. And so that's the point I'm trying to make is a lot of people think from the outside that security is exciting. Oh, we're hacking our watch while parachuting into a conference. And that's fun. I like that stuff. That's fun. But security, in my opinion, is a technical grind when you're really doing it. It's getting into this deep minutia of technical controls we must implement in development, in infrastructure, and being able to manage that on a daily basis. That's hard work. And this is where the rubber hits the road in application security. So, the key thing is that any kind of turnkey standard is not going to help you completely. You want to go through a vetting process and go through this list of requirements and understand your organization standards. Understand what your internal GRC and risk group cares about. Understand the unique parts of your environments and be able to go through a process where you're tailoring these requirements for your organization. So one of the things that we recommend at the ASVS group, at the Application Security Verification Standard group, is that you take the initial standard and fork it for your organization. It should only take you like a couple hours to do this, and you want to have the right stakeholders in the room. Get your developers, get your leads, get your software leads, get your compliance GRC team involved, and work together to build your own standard forked off of ASVS. And add your, like for example, we have like 30 requirements on authentication that are based off of NIST 863B. Anyone heard of this? NIST 863B. Why should we have all read that? What is that standard? What is that? That is an actual guideline from the federal government. We all should be reading this. This is the digital identity guidelines for the U.S. federal government, written primarily by Jim Fenton, one of the best identity changes we've seen in the standards world in a long time. I'll talk about some of this. So you want to tailor, and again, so in our standard, we list those requirements. But you may want to fork it and say, please use our company X authentication system using these 3 rules, and you're done and you're out. That might be an acceptable rule for your developers. For my developers who are building authentication systems, I want 30 granular requirements how to do that right. So go through a forking process, and now you have your standard. Here's one more hint. When I've gone through the forking process of this standard with certain companies, a lot of times security wants to assert themselves. No, this must be in. For your first phase, it's like any good government regulation. This is my trick. When I first bring this standard into a company and go through a forking process, I make sure it's not security who leads that decision-making process. I make sure it's the developers. You know why? Because when we leave that meeting, every single requirement that we've picked, who made the choice? Developers did. Do you think this is right? And when you ask a developer, do you think this security requirement matters? Well, you're giving them a choice. You're letting them drive. We walk out of the meeting with a list of requirements that the developers picked, and guess who owns it now? Developers own it. They got to have a say. Now, as a security person, I want to make choices that developers disagree with. So this is like good legislation, right? I get the developers to pick it, they start using it, and then I'll start changing it over time, little by little. Like any good legislation. Just get it in there. It's a little bit of social engineering. But it's boiling. It's for good though, and this is a soft skill that's fundamental to doing AppSec right, in my opinion, because developers are almost never given clear security requirements. This is a complete failure of any SDLC, and if you get developers to choose those requirements, they own it, and now you have a standard that we can all agree upon from that point on in development. Let's go to level 2. Let's talk about security frameworks and libraries. The unfortunate truth is that probably 90% of the code that's running in our applications is not from your developers. It's from third-party libraries. I was working at a high security environment once, and the CISO told me, do you realize that 90% of our code running in production was probably written by people that we would never let in the building? Or we would never let in the state, for that matter, or let in the country, yet 90% of that code is what we depend upon to survive in this organization. Let's revisit that. So that really spun my head when someone first told me that. And this is about 5 or 6 years ago, back when the problem of third-party libraries began to become well-known and become more problematic. I did a lot of coding back in like 2015 to 2018. These are some of the things I ran into when I was last, working 100 hours a week slinging code. I was getting a Jenkins environment up and running to do DevOps. This is a build environment where I can run security tests and all kinds of extra quality checks as developers are building their application. And this had all my code in it, all my security keys in it, everything. And there's a remote code execution in Jenkins, which means someone on my network in my organization could find this turnkey attack in Metasploit, point to my Jenkins, boop, and become an admin on it like that in one shot. So that's the keys to my kingdom. This is how I deploy software, and you've got to keep this up to date. I was at a company. The reason this is kind of neat, because I was at a company recently running Jenkins, and I'm like, have you updated Jenkins recently? They're like, no, we don't update that. It works. We don't want to touch it. And so they were running a version like this year that had this vulnerability in it. I'm like, oops, yeah, you may want to update more than once every 4 years is the takeaway here. Here's Struts, probably one of the, at least back in this era, this is one of the most popular software frameworks for Java. Struts and Spring, the two big ones. So Struts had remote code execution in 2016. We're going to come back to this in just a bit. How about this? Adobe software, XXE. This lets me read files off your file server with one request. XMP Toolkit, one request, and I got the password file off a Unix box. This is a big vulnerability. Or how about Apache Poi? I like this. It's a Hawaiian word, but more importantly, it's a Java tool to analyze Microsoft files. So I can upload Microsoft files to this library. It will let me compose it and change it and programmatically look at it. A really important part when you're dealing with file uploads of Microsoft documents. And guess what? And Microsoft documents are just XML. So one badly formed XML object, bloop, to your server, and I got your password file or any other file I want. It's a game over event. All because of insecure third-party libraries that are heavily, commonly used throughout the world today. Why do we care about this vulnerability? Here's another remote code execution in Struts from 2017. Anybody know why we all care about this vulnerability in a big way? It took down Equifax. And so on March, if I got my dates correctly, I believe it was March 17th, 2017. I'm probably off by about a week, but I'm close. So just go with this dramatic interpretation of the events. Don't worry. So around March 17th, Struts released a patch. Struts 2 released a patch to patch remote code execution. And Struts was Equifax was mostly on top of this and patched most of their systems. They did not patch a few, like one in particular. Guess how long it took before attackers were going after this server that was not patched properly? The patch came out March 17th, 2017. When did the attacks against Equifax actually begin? That would be 3 days, 72 hours later after the announcement, the attacks began. You look at studies from IBM, who study this with a lot of research in detail. If we go back about 15 years, when a vulnerability patch was released, it took about 45 days before exploits began. Today, it's a day to 3 days. So what does that mean to all of us who depend upon third-party software? Anyone ever hear of the Popeil pasta maker before? It's an infomercial. What's the catchphrase of the He's like, what are you talking about, Jim? We went from third-party software to infomercial pasta makers. Don't worry, I'm going to bring it all back. I'm going to bring it all back, trust me. What was the saying of the Popeil pasta maker, the marketing slogan? Anyone remember this? Remember, Ron Popeil is my personal hero, first of all. He said, you set it and forget it. Remember that? Set it and forget it. This is how most of us treat third-party software. We go and grab the library off the internet, we see if it works, we drop it in our project, we set it, and we forget it, and move on. Don't update it. This is how most of us roll. In fact, I was told to do this by my boss for most of my career, right? You get the library working, and don't update it. You're going to break things. And that doesn't work anymore. You now have to set it and check it every single freaking day. And the moment an update is available, you have to rock that out and deal with the problems and fix it and then go forward. This makes our life difficult. It took 3 days before the attacks began. And with other research we see, it takes a day or two. When there's a patch out for third-party software, you want security, you should be updating right away and dealing with the regression problems right away as well. And guess who wants to do this? That would be nobody. But there's a whole industry cropping up that provide these tools to manage your third-party libraries. Let's look at some from open source. So for the world, at the OWASP Foundation, our best third-party library tool is the Dependency Check project from Jeremy Long. This could be easily a commercial tool. It's licensed pretty permissively. Grab it and make a company out of it. You make a lot of money. It's that professional of a product. It supports Java. It supports .NET, many other languages. We have different data tracking tools that attach to it. We have plugins to every kind of build environment there is. So this is Dependency Check from the OWASP Foundation, one of our main flagship projects. You point this at a code base, and it will alert you of what third-party libraries you're using that have known security bugs. There's a nice and easy way to get started with this kind of tooling from an open source project. There's also Maven security versions for the Java world, which is from Sonatype, another open source project doing the same. In the .NET world, we have RetireNet, and also Dependency Check supports .NET. In the world of JavaScript, it's insane. This is JavaScript third-party libraries. It's pushed past 900,000 in just a month or two ago. And so there's our Ofenthal's project, retire.js. There's a plugin to a web browser to alert you when you're using insecure JavaScript libraries. There's the NPM audit tool, which is awesome. It will let you know the security history of any JavaScript library and NPM. That's the main repo for JavaScript developers today. Then there's NodeSource. This is commercial, but it's really, I'm not trying to endorse NodeSource, but I like what they're doing. They provide a repo that they curate. They go through all the major libraries in use today. They go through careful analysis to make sure those libraries are as secure as they can verify, and put those verified modules in a commercial repo for developers who pay for their service. I'm not trying to push their service, but the idea of giving developers like a library suite that's already been reviewed is a really powerful idea so they can move forward. And so be careful. Every app has these issues. We want to verify and use automation periodically, daily, hourly, every build, every compile, to see if your libraries are out of date. And when you see one out of date, you got to move now. When it's a critical, exploitable issue, you got to move now and keep that out of date. There are a lot of vendors here. There's open source. There's a whole suite of tools and industry around just this problem. And I encourage you to take it seriously. To this day, every time I go to an organization, I see major insecure libraries that would require a quick fix. So it's something we have to look at that we're not great at. Let's go C3, secure database access. A lot of us know this already. The main kind of concern, again, we're looking at the OWASP proactive controls. We're talking about the top 10 types of defenses that all developers need to get right in order to build and deploy secure software. We're now looking at the third control group around securing database access. How do you stop SQL injection? Some people tell me you validate data. The firewall community tells me this. The compensating control community tells me this. Those that are doing like RASP and IAS tend to tell me this. But I don't like validation as a defense in most of software. I'm going to mention validation, but I don't depend on validation. Here's why. Is this legit? Is this a legit email that we see on screen here? What do you think? Who votes this is a valid email address? Who votes this is not a valid email address? Who is not like raising their hand? Okay, you just rose your hand. Okay, this is not only a valid email address, it's live. So if you don't believe, this is one of my email addresses that's live right now. If you don't believe me that this is a valid email address, go ahead and send me a hello. I will not track your email. I'll respond with one word only. I will say, believe, because it's real. So what's the point I'm trying to make here? The point I'm trying to make is that even valid data can cause injection. Here's a basic search query against the email address I just changed my profile to. There's the new email address. That's a live, active, valid. Go ahead and send me email there. But if you notice, it's a snippet of SQL that when I add it to a query leads to injection. Anyone see this? Select ID, social security number, credit card number, mother's maiden name from the customer table where the email is Jim or 1 does not equal manicode.com. What does that resolve to? 1 does not equal manicode. That's always true. When you have an or true, all your where clause goes away, and I just dumped the entire customer table with the malicious email address. So even valid data can cause injection. If you want to, in fact, when you look at code, SQL injection appears very quickly. I'm assembling a query where I'm adding a variable to it directly, and it's not going to help. So the point, that's injection. We want to use a parameterized query. If you're new at AppSec, if you're an executive or a security executive, you're approaching your organization for the first time, and you're talking about application security, and developer leads are like, security, I thought you were taking care of that. So that means they're not doing security. Who here is approaching a company doing application security for the first time, in the last couple of months? So a few of you, so it's like 3 or 4. Here's my recommendation. Go check for SQL injection only in every application you're working on and go fix it as a sprint for your entire team sprinting together. Here's why this is important. What a lot of people like to do when they're trying to do security remediation, they do death marches. They take 1 or 2 skilled developers, because they don't want to disturb the rest of the people. They take 1 or 2 skilled developers and say, you're going to go fix all the SQL injection, because you're an expert at security. We need your help. Go fix all the security bugs. They take 1 skilled developer and have them fix bugs. This is total bullshit, waste of time. Here's why. You're going to take 1 expert who gets it already and have them go fix a lot of bugs. What about the other 100 developers? What are they doing? They're making more bugs. They're making more bugs. They're not learning. They're doing functionality, rocking out the same mistakes. So it's critical when you go down a remediation path that you sprint as a team to facilitate learning, to make sure you have cross-pollination of proper design patterns. Everyone on your team should know about query parameterization. It's easy to fix. It stops the most intense vulnerability out there. And I just need to use placeholders, these question marks, and use binding statements to bind data into those placeholders. Your performance goes up significantly of your database access, and you stop the main attack against applications. You stop injection. Your whole team should know this. When you're hiring people, if they don't know query parameterization, they shouldn't be coding for you unless you train them or unless you teach them how to do this stuff. You know, as a side note, I don't think anyone should be allowed to authenticate to the corporation until they pass a test. So you want to authenticate to my corp? No problem. You need to pass this basic awareness test about phishing and similar. You can't pass a test, you can't log in. Sorry. Go take the test again. And now you want admin access. You should be tested. Do you understand advanced security responsibility to be an admin? Oh, you can't pass a test? You don't get to be admin. And a lot of intelligence agencies, there's a lot of older professionals who aren't really skilled at computers. And when they get caught in phishing tests, they lose access. And they should. Just something to think about. Bless you. And I think the same should be for developers. You can't pass a test on basic secure coding. You shouldn't be coding. Go back and take the class again. Go read that training manual again. Don't code until you get the basics at least. You know who wants to hear this? Nobody. They hire developers no code. Go whip out code. We'll figure out security later. And that's expensive. Okay, so the takeaway here is one SQL injection can lead to complete data loss. Make sure you're doing query parameterization everywhere. The tooling that we use today, like static analysis, that's code scanning, or dynamic analysis, is really good at finding SQL injection. You should be testing, when you're actively building applications, you should be testing for this stuff every day. Catch it early, fix it early, reduce the window of exposure, make sure everybody on your team understands the basics of secure coding. We're looking at the OWASP proactive controls. We've got about 20 minutes left. We're looking at we're looking at escaping and encoding. This is the main defense that we need to diffuse other types of injection. The main injection type that we looked at is SQL injection, of course. We stopped that with query parameterization, which we just looked at. But every other kind of injection requires a technique called escaping. In fact, when you do query parameterization, the code-level drivers that talk to your database, they do escaping on their own. I wouldn't do this yourself. Let the drivers do this. But part of parameterization is escaping. Let's look at encoding, though. So one of the first things we want to do to build secure web applications to stop cross-site scripting is to use an encoding library. We have Python's Jinja library. .NET has a built-in encoder. Java has an OWASP project that does encoding that's under active development. PHP has it built into their frameworks. Ruby on Rails has a util library with escaping. So this concept of doing escaping and encoding in software development, we see this in every major language. And what does this mean? Let's look at the user interface world. When I deliver this piece of content to the browser. Let's say I'm allowing a user to author content. And in their content, they give me this character. Hey, Dr. Collins. Hey, Justin. Justin. Hey, Justin. How you doing, Justin? When the browser gets this character, what does the browser think of this character? Is this code or display data to the browser? It thinks it's code. Thank you, doctor. It thinks it's code. And that's the problem. Many characters that a user may want to type in, the browser interprets it as code, and this leads to me being able, as an attacker, being able to inject JavaScript, evil JavaScript, into your application. It can steal your data, trap keystrokes, deface the website, all kinds of vicious attacks. Dr. Collins, how can I convert this less than symbol so it's to the browser, so the browser thinks of it as just display data? What would that be? HTML encoding. You know what's the HTML encoded sequence for less than? Ampersand LT semicolon. When you send this, I know Dr. Collins knows this. Thank you for playing, Dr. Collins. So ampersand LT semicolon is it called an HTML entity? It's the code for the less than symbol. When you send this down to the browser, it will be a display of less than and not be treated as code. For example, this is a live attack. This is my favorite attack because it's silent. No one will, when this attack launches, the victim is not going to notice it happening, right? It's invisible. It also happens automatically. So here's a scenario. Suppose we're on a bank and the bank has a social feature where their top investors can now chat with each other. I saw this on a bank recently. When they get other investors to chit-chat, they buy stock together, and they buy more stock, and they get more fees. So suppose this investor chat room had a major vulnerability. When I display data, it will execute that message as JavaScript in someone else's browser. This message would build a URL to my website and grab a copy of the cookie of the victim and then build an invisible image and load the image, and loading the image will send your cookie to my server. And if I can steal your cookie, I can hijack your account. Maybe I'll buy stock. Maybe I'll buy stock that I want, make you buy stock to make my portfolio look better, or something weird like that. And so when you display this attack and you're properly using an encoder, the attack's converted to this. This is not going to launch. It won't execute. It will display the code, ampersand LT semicolon, ampersand greater than semicolon. It will display the code, but we've rendered it to a form that will not execute. This is why encoding is so important. Whenever we do encoding, we convert data to a form that will execute in the parser in question to a form that will not execute and is just a string, just display data, or innocent form. This is one of the most important concepts in secure development. When it comes to cross-site scripting, there's many other things we want to get right, but this is a big piece of the puzzle. And luckily, our tools are really good at finding cross-site scripting. We have a lot of material at the OWASP Foundation to help you get this right. And the heart of all XSS defense is either manually doing encoding or using some kind of framework that will do this for you. As a quick note, encoding comes up in many other areas. I see a lot of LDAP still being developed to this day. So if I'm going to place untrusted data into an LDAP mechanism, then I want to encode that for LDAP or encode it for a distinguished name. I just want to quickly show you that encoding, it's esoteric. A lot of us don't think about it, but these different encoders for an operating system, for the browser, for LDAP, and for XML purposes, these are fundamental in avoiding injection classes of vulnerabilities. Let's look at our next topic, validate data. Now, validation of data, it's really important to security. But this validation, it's more of a hygiene topic than a we're going to perfectly fix security topic. Remember my email address earlier? That valid email address? That's still vulnerable. So please be careful of depending on this topic for security. It's more of a hygiene issue. It's meant to minimize the attack surface of your application. And the basic rule with this is all data entering your software must be validated. Even input that's not directly entered by the user can still be modified by the attacker. Something like a hidden variable, something like a cookie. These are things the user does not interact with. But as an attacker, I can still change all of this, launch it against your application, and cause harm. So every piece of data entering your software should go through some kind of validation layer. There are three kinds of validation. I'm either doing some kind of exact match validation, like I have a list of possible country codes. Your input better be one of those specific country codes, or you're attacking me. I'm going to reject. Or we look for known good with a regular expression. We define a pattern to what good data is and reject everything else. Or known bad. This is the least effective, where we have like a firewall that's actively looking for an attack, like a web application firewall, looking for an attack and blocking that attack. This is the weakest layer. This is a better layer. This is the best layer of when you're doing validation. The other thing I want you to think about is that as software goes through a maturation phase, I've been working on one application maybe for about 7 years now for some friends of mine, an old piece of enterprise software that we wrote for a friend company of ours. And so what we found is that when we first built the application, we did validation for US English, because we just supported English. So we had very clear patterns for username. Uppercase and lowercase letters only, plus numbers, that's it. A very clear validation rule. It can only be between 3 characters and 25 characters. Clear rule. Now we support Mandarin, and we support Spanish, and we support German, and we support 20 other languages. What happened to our validation rules? What's that? They break. So I have to keep adding more characters. And how easy is it to support a validation rule that supports Arabic, Mandarin, full Chinese, and Japanese? What happened to my validation? It's all effed up now. and English and Spanish. So what we end up doing is we gave up on regular expressions. And we just said, curly bracket P. Anybody in the world of regular expressions know what the rule curly bracket P is? All printable characters. So we gave up. But what we did do is we still did bounds checking. We said the input must be less than 20 characters or less than 50 characters based on the field. The point I'm trying to make is validation tends to get weaker over time as we need to support more languages and more features. So I rarely depend on validation to save me from a security point of view. Two more topics come up in the world of validation that's really important. Is open redirects and URL validation. This is a very exciting topic, trust me. So redirects are really important because they show up a lot in the world of modern protocols, in particular OAuth and OpenID Connect. These are some of the biggest up-and-coming protocols in the world of identity. And we have to feed them a URL to redirect back to our server as part of this mechanism. So here I'm going to say, if the URL equals manicode.com, then redirect there. That's a good rule. Or if the URL starts with manicode.com/, then allow that redirect. So whenever you're allowing a feature to redirect to another URL, we have to strictly as possible, validate that that's a URL to one of our domains. And if suppose I did this. So you see how I'm saying URL starts with manicode.com/? What if I forgot to put that / at the end? If I said URL starts with manicode.com and there was no /, how would you break through that rule? Go ahead. Yeah, manicode.com, .evil.com, and I just broke through your rule. So the point I'm trying to make is these validation rules for securing redirects are very difficult to get right. A lot of people say starts with your domain or similar. Those are all circumventable. So do strict exact match URL validation as much as you can. Or how about this? When we're deep in the browser, if I can hand you a JavaScript link, it will execute as an attack. So you can't, this code is all blanked out because of the projector, whatever. But the point I want to make here is I need to build a validator in React, one of the most popular user interface frameworks in the world right now, by a wide margin. It beat Angular. Angular's junk, sorry. It's beating out Vue. Most modern UI development that I see is now done in React. And if I can get a JavaScript URL into React, it will execute as cross-site scripting. That's how I bypass React. So what you can't see here is I'm saying, is this URL safe? If it's not HTTP or HTTPS, it's going to reject the link. So if the link is JavaScript, it's not going to be legal anymore. I need this kind of specialized validation when I'm using modern frameworks very often. All right, let's look at C6, digital identity. Now, this is a ginormous topic. We're looking at the OWASP proactive controls. It's a top 10 list. We're looking at item 6 on this list about identity. We just saw Wendy talking about this in the keynote for a good hour. I'm only going to talk about a few things here. The identity has changed in that if you're a company and you're building your login mechanism from scratch, I question that today. There's so many identity solutions out there. For example, I'm building a new service. I'm not going to advertise here, but I'm working on a service, something I'm working on. You know what I did for login? I did Google, LinkedIn, and Twitter login. And some of my security friends are, why are you doing that? That's horrible. I'm like, no, it's not. Do you think I'm going to be able to write my own login system from scratch securely versus just flipping on Google login? No, I could build a secure login mechanism. I need a good 4,000 hours of time to get that going because it's hard. So, and this is something, Troy Hunt told me this once, and I called BS on him. Hey, Troy, wherever you are, it's now 3 years later. Yeah, dude, you're right. So, authentication's hard. I really want to avoid building it myself. I want to use an identity provider like a Duo, like an Okta, like Google Login if I want to be cheap, whatever. I want to avoid doing this myself. I wish that wasn't the case, but it's the reality of today. Here's some reasons. And by the way, the latest publication from the U.S. government on identity changes the whole world of password policy. This is awesome. What they say is It must be 8 characters or longer. I don't agree. In the ASVS, we say 12 characters or longer if you're doing multi-factor, or 16 characters or longer if you're not doing multi-factor. And by the way, if I can log into your corporate login without multi-factor, that is fucking negligence. You are negligent in your duty of running your company if you allow me as an employee to log in without multi-factor. It's effing 2019, folks. Multi-factor for customer login, that's debatable. Like Amazon offers multi-factor, but they don't force it on you. That's consumer stuff. That's a different story. But for your enterprise, corporate login at the enterprise, I see a lot of big enterprises that have 8-character passwords for corporate login. That is effing negligence. What the bleep are you doing at your company? Seriously. Multi-factor is not a nice to have anymore. It is the bare minimum for identity. And so I'm not a gentle human being all the time. I was in a meeting with the CFO, with the CISO, with the CEO, the lead architect, and they spent 20 minutes telling me why multi-factor was not important. And I lost my cool. I'm like, what the F are you idiots doing? And that didn't, by the way, that kind of communication didn't serve my cause very well. I just after an hour of talking about why multi-factor is not important, I just went to full head explode. What the bleep why are we wasting? Anyways, sorry. Okay, sorry.
It's not a Google Titan, right?
What's that?
The Google Titan, the Bluetooth protocol. So you can hijack the second factor.
Yeah, of course multi-factor has problems. Of course there are issues with it. According to NIST, what they're suggesting is that multi-factor over email is like level 1. Multi-factor SMS over a phone, that's level 2 for sensitive data only. But if your application, like the state or county, if you have personal safety at risk, if you have billions of dollars of assets at risk, if you have the private data of millions of users at risk, then you should be using YubiKeys or smart cards. End of story. Any kind of multi-factor where you have a number in it is crap. Why? That's a common multi-factor, right? I go get my RSAT, read off a number, type it in. This is garbage for multi-factor. Why? Because it's phishable. All of it's phishable. You want to have a chance of stopping phishing, you've got to use smart cards and YubiKey type authentication. Nobody wants to hear this, I know. Very few companies do this to this day. That's the only good kind of authentication we have today. We see that in European standards. We see that in U.S. federal standards. And again, it's easy as a theorist to say this. I'll even take a step further. You want to do real corporate authentication, then use hardware tokens for everybody in your company, a YubiKey, some kind of smart card, and that's the bare minimum for securing your organization today. Nobody wants to hear this. It's a harsh truth, but it's what all the modern standards are saying that are cropping up right now. By the way, password policy is all different now. 12 characters or more. Block context-specific passwords. We shouldn't see the word ISSA in any password for this conference. Check against a list of common passwords. Look at Daniel Miessler's work. You'll see he has databases of thousands of common passwords that you should be blocking within your organization. Check against a list of breached username password pairs. This is a technique called credential stuffing, where I see Yahoo had 7 billion passwords and usernames stolen and leaked to the public. Attackers will grab those username password pairs from different breaches and use them at your bank, at your healthcare, at your email system. This is using a breached username password from one website and trying to do it at another website because users reuse their passwords. And so it's called credential stuffing. And this is one of the top ways people attack your system. So we should be defending against that in our authentication. Throttle brute force attempts. Don't stop these special character rules. Uppercase, lowercase, number, special character. They're useless. Stop doing that. Don't use password security questions or hints. I'll get them on social media. No more mandatory expiration every 3 months. It makes people use patterns and it's useless. And allow Unicode in passwords like emoji and similar. So what they're saying is stop these uppercase, lowercase password rules. Instead, map your passwords to modern threats and have that defense ready in your authentication system. Guess who has that in play today? Almost no one. So the whole world of passwords and identity management has radically changed. I know you came here just to go to a nice talk, right? But guess what? You got homework. I want you to go read 863.3 or 863B. There will be a test in about 2 weeks. I will find you and test you. So no, I'm just joking. But seriously, we all want to learn more about this stuff. Identity is a big part of our jobs. This is a brilliant document. It's a hard read. Go give it a read. Go get about 3 reads, and it will be a very valuable use of your time. A few quick notes as I finish up here. Yeah, I got the blanks. I want to say one thing. As we go to access control, please read the ABAC standard. Hard coding roles in code is very fragile. You should be coding permissions and features in your code as opposed to roles. Protect data everywhere. You want to use strong HTTPS everywhere. Is there a good excuse to use HTTP anywhere? Is there a good excuse for HTTP anywhere? No. There's not anywhere. We want to use HTTPS everywhere and good key vaults to store our crypto keys to do cryptographic storage. I'm gonna jump ahead a bit. We want to implement good security logging and monitoring. Here's my last note, and I'll close the talk. For developers doing logging, if you only log 3 things rigorously, if you only log access control failures, all of your authentication events, and log all of your validation failures. If that's the only thing you log, one more time, all access control server failures, all authentication events, and all validation failures. If that's all you give me, I got everything I need to rock out a good monitoring program. So I used up my time. If you have any questions for me beyond this talk, I'm jim@manico.com. I'll answer questions off stage. Thank you all for being here at ISSA Summit 11. Have a wonderful conference, everybody. All right. Question. What they're saying is stop credential stuffing, block common passwords, throttle brute force attacks, stop putting context words in your passwords, make them 8 characters or longer, and drop all the other nonsense rules. This is the biggest departure in all of password theory that we've seen in 20 years. But so what I'm saying is go read NIST 863B. This is the most correct standard on passwords, and it's changed everything anyone has said about passwords in the last 20 years. It's a radical departure. Correct. Thank you again. Thanks all. Any other questions? Enjoy the rest of your conference. Have a great day, everyone. All right.